Let's prove this trig identity. So the method for a lot of these is to start with what you have on one side, do some calculations so that you get what you want on the other side. You have shown an equivalence, you have proved the trig identity. So let's try that. A good first step for a lot of these is to convert everything in terms of sines and cosines. So if we do that, we're gonna get this, right? Secant is the reciprocal of cosine, cosecant is the reciprocal of sine, tangent is sine over cosine, cotangent is the reciprocal of that, cosine over sine. Next, we notice that there's a lot going on in our numerator and our denominator, but they're both fractions being added to each other. So why don't we find a common denominator and combine them like we did in first grade, right? So our common denominator is actually going to be sine x times cosine x on both the top and the bottom. So we multiply by what we're missing, multiply across. Because we have a common denominator, we're going to add the numerators, and we end up with this, which is basically a big fraction divided by a big fraction. So when we have fractions divided by fractions, we can actually keep, change, flip, right? So we're going to keep what we have in our numerator, that first big fraction. We're going to change the division into a multiplication, and then we're going to flip what we have in our denominator. So if we do that, we're going to end up with this, which is starting to look pretty nice, right? Because sine x times cosine x is across from sine x times cosine x. So these things cancel, right? Anything divided by itself is 1. And then we should recognize that sine squared x plus cosine squared x is equal to 1, right? This is one of the most common Pythagorean identities. You should know this if you're in trig. So putting that all together, we end up with exactly what we want. That, our left side, is equal to sine of x plus cosine of x. That's really it.